Imagine taking the very concept of internet exchanges, those critical hubs where networks connect and share data, and launching it beyond our planet. DE-CIX, a global leader in internet exchange services, is doing just that with its groundbreaking SpaceIX initiative. But here's where it gets controversial. Can the principles that govern terrestrial internet infrastructure truly be adapted to the harsh and complex environment of space? And what does this mean for the future of global connectivity? DE-CIX recently unveiled plans to extend its proven interconnection model into low Earth orbit, LEO, aiming to link satellite constellations not only with each other, but also with networks on the ground. This ambitious project lays the foundation for what could be the first orbital internet exchanges, effectively creating a network in space that mirrors the interconnected web we rely on here on Earth. With over 30 years of experience and more than 4,000 networks connected across 60+ internet exchange points worldwide, DE-CIX is leveraging its deep expertise to pioneer this new frontier. Wherever networks exist, interconnection must follow, says Ivo Ivanov, CEO of DE-CIX. Our goal is to apply the same principles that have made terrestrial internet exchanges successful to the infrastructure orbiting our planet. A key part of this vision involves collaboration with the European Space Agency's Ophelius project and the German Aerospace Center, DLR. Together, they are developing laser-based communication links between satellites, which promise much faster data transmission compared to traditional radio waves. However, these optical links come with their own set of challenges, such as dealing with atmospheric interference, requiring new communication protocols to ensure reliability. While Ophelius primarily focuses on satellite-to-ground communication, DE-CIX's SpaceIX initiative is pushing the envelope by enabling large-scale interconnection directly between space-based systems. This could revolutionize how data flows in orbit, creating a resilient, high-speed network that supports everything from global broadband to Internet of Things, IoT devices, and artificial intelligence applications. A striking example of terrestrial and orbital networks beginning to merge occurred in August 2025, when DE-CIX India became the first internet exchange in the country to integrate Starlink, SpaceX's satellite broadband service, into its interconnection ecosystem. This milestone highlights the growing importance of low-latency connections for applications that demand real-time data exchange, such as remote surgery, autonomous vehicles, and financial trading. The stakes are high. The space economy is projected to soar to $1.8 trillion by 2035, fueled by advancements in global broadband, IoT, AI, and remote sensing technologies. British astronaut Tim Peake, a strategic advisor for Axiom Space and a vocal advocate for the UK's role in space innovation, has even discussed the potential for data centers in orbit. These orbital data centers could dramatically reduce latency and expand computing power directly in space, bypassing the delays inherent in Earth-based data processing. Axiom Space plans to launch its first 2 orbital data center, ODC nodes, into LEO by the end of 2025. These ODCs will provide secure, scalable cloud services, including data storage, processing, and AI machine learning capabilities, directly to satellites, constellations, and other spacecraft. Earlier this year, Axiom partnered with Red Hat to send a prototype data processing unit, AX-DCU-1, to the International Space Station, marking a significant step toward this vision. Peake explains, "By the mid-2030s, we expect the cost of using an orbital data center to be on par with traditional cloud servers on Earth. This is possible because space offers clean, limitless energy and the ability to dissipate heat into the vacuum without environmental impact." But here's the part most people miss. While the technical possibilities are exciting, the shift to space-based internet infrastructure raises complex questions about governance, security, and equitable access. Who will control these orbital networks? How will data privacy be maintained? And what happens if conflicts arise over this new digital frontier? As DE-CIX and its partners push the boundaries of connectivity beyond Earth, these questions become more urgent. Are we ready to embrace a future where the internet truly spans the globe and beyond? What do you think about the idea of orbital internet exchanges and data centers? Could this be the next giant leap for global communication? Or are there risks we haven't fully considered? Share your thoughts and join the conversation below.